So if you head out west, but then also go north, so we're going over to the Pacific Northwest, you'll notice that there are still these gorgeous canyons, but rather than being red and orange and largely unvegetated like the Grand Canyon, the canyons up there are really dark in color and have luscious green vegetation growing on top of it. These canyons formed within the ColumbiaPalteau. So the Colorado Plateau is down near the Grand Canyon in the southwest. ColumbiaPalteau is up in the northwest. The ColumbiaPalteau is named for the Columbia River, which carved it. The Columbia River is actually what separates the states of Washington and Oregon on their coast there. And unlike the Colorado Plateau to the south, which is composed of layers of sedimentary rock, the ColumbiaPalteau to the north was built almost entirely by volcanic activity. But during the Miocene, about 17,000 years ago, basaltic lavas like those that pour from mid-ocean ridges erupted along deep fissures approximately parallel to the Washington-Idaho border. Okay, so these cracks within the Earth's surface opened up and lava spewed out. And because it was basaltic lava, it ran really easily, flowed really easily, and covered a huge amount of area. It buried more than 500,000 square kilometers beneath a layer of lava. And that's shown in this pink area in this figure. Okay. And that's why when you look at the Columbia River Gorge, it's eroded down into these dark basaltic lava layers. You can also see multiple eruptions here. Each layer within this canyon is a different volcanic eruption. So these massive eruptions of basalt were actually generated by a mantle plume that created a hotspot of volcanic activity within the Earth's crust, right? So remember that hotspots occur when a plume of magma upwells from the asthenosphere and causes a thinning of the crust above it and volcanic eruptions on the surface there. All right, so there was a hotspot beneath the ColumbiaPalteau that created these eruptions. And even though hotspots remain where they are, right? They remain in position. The plate above them moves because it's a tectonic plate, which means that just like the Hawaiian Islands are moving farther and farther and farther away from their hotspot, the ColumbiaPalteau is moving farther and farther and farther away from its hotspot. So as the North American tectonic plate moved westward, that mantle plume remained stationary, and eventually it caused the ColumbiaPalteau to move far away from the hotspot. The hotspot is currently underneath Yellowstone National Park. So this is a picture of Yellowstone National Park. There's still a lot of volcanic activity here today. That's where we get a lot of these gorgeous hot pools. It's where we get the geysers, right? A lot of really warm magmatic activity here in Yellowstone. Yellowstone is actually just within a huge volcanic crater, right? The dip at the top of the volcano. That's what Yellowstone National Park is. So the Yellowstone hotspot eruptions have been more violent than the ones that created the ColumbiaPalteau. The most violent of these eruptions occurred about 600,000 years ago, and it resulted in the formation of the Yellowstone caldera, right? So that's that circular area. You can think of it as a crater at the top of the volcano. It's that circular subsided area atop the hotspot that after the eruption of Yellowstone kind of fell back in, collapsed back in. And this is what encompasses most of Yellowstone National Park. So Yellowstone National Park is within the crater, within the caldera of this massive volcano. As I said, the biggest eruption occurred 600,000 years ago, but the most recent volcanic eruption occurred about 70,000 years ago. All right, so this volcano is by no means dead, by no means extinct. It could possibly erupt again. Here's an image showing just how far away from the hotspot the ash from these volcanic eruptions went. So the Yellowstone Plateau is shown there in dark red. And you can see in lighter red in pink how far away the ash was carried from these eruptions. So 600,000 years ago, The ash was carried all the way down to Texas, all the way down to Louisiana, made it all the way over to California. And we actually see a layer of ash preserved in the geologic record from this eruption. That's how we know this eruption occurred, is because we see that layer of ash preserved. Now, today, the Yellowstone hotspot displays only geyser or steam emission activity. As a result of the groundwater interacting with the really hot subsurface, the magma below the surface. However, in the future, it is possible for Yellowstone to erupt again. And we know that Yellowstone is a super volcano. It is huge, which means if it erupted again, there could be devastating consequences for people living in the area and way outside of the area. So this image shows the possible eruption pattern of Yellowstone. Pretty much everybody within Wyoming, a lot of people within Idaho, Montana would be killed. Okay? And then ash would blanket a large part of the West and Midwest. This would definitely shut down airline travel. This would kill the vast majority of the crops that we use to grow and eat and trade and generate our economy. This would be a massive global economic crash. Right? Now, I don't think this is going to happen within our lifetimes. Remember, the last volcanic eruption occurred 70,000 years ago. So it's probably not going to occur within our lifetime, but it is possible.